prompt-driven test automation with Chrome DevTools. I'm curious to see how far I can take building a fully prompt-driven test automation system with Claude code. So in this session we're going to take our spec file about deterministic test automation. I've worked through that, I've refined it. We're going to take what we've already looked at with test cases that are written in markdown, and we're going to use Claude code to come up with some commands that will enable us to discover the best ways to do test automation with prompts, learn from that discovery session, generate some YAML files that we can use consistently, and then validate that test automation YAML file with Chrome DevTools and the MCP in Chrome. So the whole concept, a system of prompts to generate reliable automated test creation and execution. So we start with those core test cases that we've developed and written in markdown. So if you remember, in previous sessions we managed to work out a way to create test cases from recordings of our screen and turn those into markdown test cases in a structured format that our agentic coding tool can use to interpret and turn into automated tests. Then in the previous session I also talked about a deterministic testing approach to AI browser testing. I've taken that document and I've refined it, and I will make these prompts available in a future session towards the end of this week, but I came up with a version 2 of this deterministic test automation strategy. And in here I worked through with Claude with various prompts and ideas and concepts and experience that I've had to build out a core concept around creating test automation scripts with AI coding tools. And that was based around what we came up with as a compilation process, so that we take a markdown test case and we walk it through a number of steps to turn it into a runnable YAML file the AI tool can use in conjunction with the Chrome DevTools MCP. So the core philosophy around this is taking our markdown files, compiling them into a YAML code or YAML file that our AI tools can use, execute those, and then create this continuous learning feedback loop so that we can enhance our scripts over a period of runs and time. The key concepts behind this, we wanted a single source of truth. That is the markdown test case. That is the bedrock for everything that's built subsequently. We wanted AI to handle all the complexity of converting that test case into a YAML file that we can run with the MCP server, and then we wanted to make sure that we have some sort of loop that enhances and improves and learns over time. So ultimately we've got repeatability, and as it says here, AI providing that adaptability. We built this on 3 pillars. Automation aware test cases, so ultimately our markdown test cases will have some context around test automation, so they'll be well structured. We have the run twice pattern that we talked about previously, so we are going to run the first time to do a discovery session and record and capture screenshots, good locators, timings, selectors, and best ways to interpret the markdown. We'll compile that into a YAML file, and then we have this run 2 which validates what we've just done, and if it fails we can learn from it, use that feedback loop and go around the loop again to keep compiling until we get to a successful validated test execution run. So that was pillar 2, and pillar 3 was this intelligent feedback loop. So as you'll see in a subsequent session where we do more complex iterations of this, we can use lessons learned to guide how it turns our markdown test case into a YAML file for execution. So based on the concepts and techniques outlined in that document, I've then gone forward and taken the 4 core concepts in there to create these discovery commands, the learn command, the generate command, and the validate command. So those 4 commands then we'll see in our Claude code project, and we'll see these execute in a minute. So we've got the discovery command, which uses the MCP Chrome DevTools to go through, execute and have a first attempt and document everything in that discovery session. It will then use what it's documented in the output from this, which is the discovery JSON log, and it will then use that to learn in a learn phase that extracts all the automation patterns, and from that those learnings will then be saved and taken as input for the generate command, which is responsible for generating the deterministic YAML file that we can then use in the executions and the validate command to make sure that that compilation process has been successful. So all that remains then is for us to run this experiment, and let's have a look at some of the outputs and the results from this process. So the first thing to do then is just to check that our MCP server is connected and that we have that access to Chrome DevTools, and that is connected, so that's good. And then the next step then, or the first step in this process, is to use the /discover command, and that accepts the test case. So we have our add investment account test case. So I'll take that file, copy relative path, paste that in there, and we'll run that discovery command and see what we get from that. And on completion of that process then, we've added our main investment in our demo application, and Claude Code has come up with a discovery.json log file, and in that file we have got a file which details some of the best approaches to automating this particular test case with this particular type of application. So the next stage then is to use this file with the next command in the process, which is the learn step, which goes through all of this information from the discovery phase using the discovery log, and it will work out the best way to then generate this YAML file that we can use consistently for test execution runs. And the output from this stage then is our learnings.json file, and that file should contain the best approach for then generating a YAML file that we can use for our test execution phase. So next then, off the back of this learnings.json file, we can use the generate command, and this expects both the learnings file and the original test case, because this is what's going to be used to create our YAML file that drives the consistent execution of our automated test using only prompts and no code. So from that stage then, what we should have now in our test management artifacts is this testspec.yaml file, and here we go. So in this file, if we have a look at this, we have a script based on our original markdown test case that our AI coding tool can use in conjunction with the MCP Chrome DevTools to run this automated test consistently time and time again. So the only step left then, now that we've created that YAML file, is to actually validate it. So we have another command to validate it and run it for that second execution, and to give us some stats on how good that automated test is going to be. So now we're ready to run the /validate command and validate, and I'm going to close down the browser so that we start with a clean session, and we'll feed in the YAML file that's effectively our script for automated test execution of this test case, and let's see how well that test case runs. And that's running now in the browser, and you can see we've navigated to our financial applications demo app, and we'll leave that running until Claude Code has completed that execution and given us an evaluation of how effective that particular test spec is going to be. So from that then, we've got our validation results, and that file then I'd want to review, and then we're going to look at how we can feed that into our feedback loop and use that to enhance our process from start to finish by repeating those loops. But the overall validation result then from this end-to-end process is that we've got a test that's been automated, that's production ready to deploy to CI, It's got zero ambiguity, all fragility points documented and scored, maintainability, and if we go up here we can have a bit more of a detailed view of this. We've got the discovery log, learnings, test spec, and then the validation results. Again, those are the files that were created. The AI opportunities identified, discovery successfully captured, intelligent learning, deterministic YAML, self-validating tests. And in terms of a score for this particular test case, then we've got 10 out of 10 for reliability, timing, data handling, determinism, maintainability. Test selectors need monitoring for UI changes. I think that's talking about if the text on a button changes, then we're going to need to update this test and it's fully ready for CI/CD. We have gone from a markdown test case written in plain English. We've stepped through a 4-step process where we did a discovery session. We learned from that discovery session. We used those learnings to generate a YAML file, and that YAML file we then use to execute the test, and we validate it with this command. And in summary then, we've got a test case that is a single source of truth from which we compile a YAML file that can be used by AI and an MCP to run the automated tests. So no coding. We've got what I think is going to be a reliable test execution. I need to run that in a CI/CD pipeline several times. And with that, I think there still needs to be some extensive testing, but it does look like we have an end-to-end process that has got some potential here. What happens with more complex tests, we'll look in the next session. And yes, granted, it does only currently work with Chrome because I'm using the Chrome DevTools MCP, but I think this whole process would work with the Playwright MCP as well, something else to test in the future. And those are really the 2 points that I'm still curious about. How reliably will this work in a GitHub workflow? And could this work with the Playwright MCP so that we can test across multiple browsers, different browsers? But this whole process of run 1, the discovery execution, 2, learning extraction from that discovery, the YAML script generation, and then the run 2, the validation of that execution. I think that is a good structured approach to generating automated tests from prompts with an AI coding tool. So in summary then, this is an approach that I'm really interested in, and I think it's taking shape. I want one more session to look at that feedback loop and executing in a CI/CD pipeline. And as soon as I've got all of that in place, then I'll look to release this on GitHub with all of the prompts and the instructions on how you can deploy this. And perhaps some of you could help me test this in a production-like environment against other applications to see how it performs.